As James Kirk and Jean-Luc Picard had famously said, space, the final frontier, especially for growing plants. Although you'll find an awful lot of fantastical plant references in Star Trek on various fan sites, growing plants in space for food is still an exploration at best. A number of years back, I spoke with my friend, retired astronaut Leland Melvin, about his time in space. Eating a meal 70-plus miles above the Earth was quite a symbolic and profound experience for him, which I'll excerpt here.
Whenever I break bread with friends or people that I just meet, I always think about the time in space. My first flight, we were flying around the world at 17,500 miles per hour every 90 minutes. And we were eating this meal with people we used to fight against. So Dr. Peggy Whitson was the first female commander who, after this installation of the Columbus Laboratory, she invited us to dinner. She said, okay, we're going to have the meat over here. You guys bring the rehydrated vegetables. So we all float over with our bag of vegetables and we kind of mass around this table. And there are people from Russia, from Germany, from France, African American, Asian American, the first female commander. And we're listening to Sade on the iPod through the speakers as we're tasting these different meals from around the world. And that was my space smorgasbord. That was my moment where I realized where I was, because everything before that was, you're doing your task to get the job done. It's all technical and it's time, it's the time-centered. But this was a moment where you could just let your hair down, and have this incredible meal with people that you used to fight against. And I think that was the most transformative moment for me, because that also helped me get my orbital perspective.
I'll link to that entire interview because it's quite relevant to the current events of the day. But I digress because, as you heard from him, it was dehydrated vegetables that they were eating. And if it's one thing that astronauts miss the most, it's fresh veggies. But is it even possible to grow? We'll go down to Miami, Florida, and sync up with the Mr. Rogers of the plant world, Chad Husby, to talk about the collaboration that Fairchild Tropical Botanic Garden has with NASA and schools around the United States to explore what growing techniques and plant species can work best for an indoor garden in a space station. It looks cool from the outside here, with this little purple door and
yeah, we've got a whole orchid display and other things on the outside. Yeah, this is where the headquarters for what's called the Growing Beyond Earth program, that is a collaboration between Fairchild Garden and NASA. Test different plants that can be grown to eat in space. And this is a collaboration with different high schools and middle schools all across the country now, more than 40 states, and they've been several tens of thousands of students who've contributed to it so far. It started out, it's about 7-8 years ago now, when some of the staff here, the director Carl Lewis and Amy Padolf, the education director, they happened to hear some YouTube videos of some of the NASA scientists who were looking into growing vegetables in space, and they realized that this had a neat connection to plant exploration, because the tradition here of bringing in all sorts of new plants that David Fairchild started also was largely based on bringing new food plants that might have potential for improving nutrition, and one of the things that astronauts miss most when eating their freeze-dried prepared food in space was fresh vegetables. And fresh vegetables also are a way to provide vitamin K, which is hard to supply in the preserved meals that can survive the trip to space and storage in space. And so it turned out that this was a great match between the idea of trying to find new plants that could be good potential space crops, and then students are able to test these and share the data with NASA, and they can test much larger diversity of crops than NASA could test by itself. So it's a citizen science project, basically, with that students become the citizen scientists.
Well, that's great for students to be able to explore this. Even if they don't come up with anything that is workable, just the process of actually going through this and what would work and what would not. And then also just your expansion of what vegetables may be. So when we think about vegetables, we think about the traditional vegetables that we may have on our plates, but are they looking at vegetables across many different geographies and cultures in order to see which ones were the best? Because let's just be honest, maybe our typical lettuce and carrot might not actually be the ones that are going up to space with us.
Well, it's so true, because one of the big limitations of growing in space is they don't have a lot of space, because they have to grow them. Now there are these little chambers they use on the International Space Station called Veggie, which are about the size of these chambers, these little cubes here. Growing in space is one of the kind of the real edge challenges. Often the big innovations in horticulture come from growing plants, in places where it's difficult to grow them, like in cold places, or in dry places, or in really wet places that don't get as much sun. Space, you don't have gravity, which means you don't have air circulation can be a problem, and delivering water to the plants is a problem, because water, if you took a watering can or a hose in a zero gravity environment, it would go everywhere, and only a few of those drops would maybe hit the plant roots. You don't have the sun, so you have to use artificial light, like these chambers have LED lights that have both red, green, blue, and white.
How does evapotranspiration work, or does it work in space? I have all these questions.
No, it's true. It does work, but it works. You have to provide the convection, the air movement, because if you didn't have fans moving the air is very still in a zero gravity environment, and so the plant, when it's photosynthesizing, it's going to take in all the CO2 that's in its immediate surroundings, right around the leaves and stems. And that'll and then the CO2, the diffusion of the CO2 from the surrounding air is very slow compared to the process of photosynthesis taking it up. So with Earth here, we have gravity, we have the sun, different temperature, sun warming up the Earth so that hot air rises and the wind's blowing, and plants generally have plenty of forces to change the CO2 and around them and the oxygen, and give them as much as they need. But in space, we have to kind of simulate all this, and not all plants like that environment as well, and that's why it's useful to have to experiment with a bunch of these different plants. And some plants, like our full-size garden plants, wouldn't even fit in these chambers very well. So
yeah, the question of how much biomass can you get? Is it enough to make one sandwich? But if you're up there for 4 months, that's a whole different story.
Oh yeah. It's they've been trying to find different ways to make growing food in space more efficient, and one of them is choosing the right crops. One of the plants that's really performed, that was discovered by the students in this program, was extra dwarf bok choy, which is very compact, and it grows well under a variety of different conditions. And one thing, having a whole bunch of schools participate in this program, is that if you find one of these plants that grows well in 50 different schools under, they've each got, slightly different temperature and humidity regimes in their classrooms, and all sorts of other variables of how they're taken care of. And if they just perform across all those, the chances that they'll perform in the rigors of space are much better. And so the NASA scientists have really appreciated kind of having, students running these experiments all across the country in all different situations.
Yeah, and then also, if that extra dwarf bok choy that you had mentioned is performing well in something as constrained, space constraints, but I'm chunk, in space, then it would probably work well on Earth in very tight constraints.
Oh yes, very much so. That's the interesting thing is, the plant that's robust enough for space has also got virtues for, we've got all kinds of vertical gardening we want to do in urban environments on Earth, and other balconies, growing things on balconies and whatnot that have similar kinds of challenges, and growing things indoors where we don't have as much light, and we need to use our latest technologies for providing light, and the LED has been such a huge advance for providing artificial light
Now, how does nutrients work? Are they giving them like a nutrient-rich substrate? Because, you know, you're probably not taking a lot of the actinomycetes or bacteria or anything fungi in the substrate with you, or are they? You know, I guess there's like some little animals that have done well in space. Like, what is it, a rotifer, or the ones that look like little teddy bears?
Oh yeah, the tardigrades.
Tardigrades.
Yes.
But you know, when I think about nutrients, I think about like you know, growing things hydroponically and providing nutrients, or I think like in living soil, like bacteria making nitrogen available, et cetera, et cetera. How are they kind of contending with that issue within space?
They actually have to bring them up as seeds that have been sterilized, so they're actually not, they try to avoid on the space missions having all sorts of microorganisms introduced to that environment. So that's part of the challenge, is that you're having to kind of have plants that don't need a lot of other kind of soil ecology to do well. And one of the interesting things is that the plants in the Brassica family, the Brassicaceae, like bok choy is one of those, and things like cabbage and all those that are cruciferous vegetables, they actually don't need mycorrhizae, which is interesting. Even in nature, they don't have. Yeah. They kind of are able to. They make a lot of very thin fibrous roots, and they're one of the few plant groups that doesn't tend to establish those relationships. So that's been a helpful characteristic of these. And they have to use completely artificial, kind of sterile soil here, which this is. This right here is sort of a peat-based soil, but they also use, this is actually some cocoa coir.
Yeah, it looks like coconut coir.
And then there's also this material that they use. It's a clay that's heated at very high temperatures, and it's like if you were to then crush, say, a terracotta pot into the particle size of sand. And it's very stable. It won't break down into mushy clay anymore, and that provides a good growing medium for a lot of plants.
Yeah, it almost feels like a sand, but slightly different texture.
And it has characteristics that regular sand doesn't have, because it can absorb a lot of nutrient, because it has all the space inside that clay has, and it can also absorb a lot of moisture, and plants can grow well in it. So.
And are these some of the vegetables over here, or plants, or are these just like leftover from like a plant sale?
No, some of these are that, and some of these are some of the new plants that are being tested. Like the Madagascar periwinkles here, those aren't edible, for example, but they've been testing, many, I'm sure they've tested well over 100 different varieties of plants for in these chambers, and how they perform. And they've also tested they've actually tried one really innovative method called, it's where they actually harvest part of the plant and then let it regrow, like these leafy vegetables.
Yeah.
And then continue, it's sort of a continuous harvesting, and they found that they could get, with the same amount of fertilizer, about twice the edible biomass from those plants.
Wow, fascinating. These are just things that you could apply in normal life, and they're just, working under like really different constraints. That's fascinating. Also, when you mentioned brassica, I think about like the brassicas that I see in rock gardens. There's a lot of brassicas that grow well on rock gardens, like really little substrate, like you said, very superficial roots, and that spread like crazy, that seed like crazy. So that could be interesting. And to think about all the different food crops across the world, we're so limited when we go to our own supermarkets. We're so limited in like what we think we can eat, but there's just so much more available out of there if we just expand our gastronomic cuisine. Oh, yeah. Like, I'm not necessarily a big bok choy eater, but many cultures are, big bok choy eaters. And if that's what actually works in space, then that's amazing. Where do we find out the results of this research, and where do the results get posted? Where does like the public learn about this more?
There's a Twitter account that at Growing Beyond Earth that has a lot of the latest postings from different schools in the program, and the Fairchild Tropical Botanic Garden websites and the Fairchild Challenge that this is involved with, our education program, all have information. It's been an amazing collaboration, and we've even had these students a couple of years ago. They were able to do a live communication with astronauts on the International Space Station, and when the astronauts actually were able to eat some of the vegetables that they were growing that had been tested in the program, and the students could ask them questions. So it's been a real inspiration for a lot of students to see how relevant horticulture and plants and also plant exploration in terms of testing a whole bunch of new plants and thinking of new ways to grow them can be for some of our highest profile science, which is trying to get people to other planets and to grow in the most, space is probably the most challenging environments there is. So this is a laboratory where work on innovating ways, new ways to grow plants that students think of, both all the way from, we've had students in elementary school all the way through high school who have been doing this, and we have 3D printers and have laser engravers and regular engravers over in here. So we have all the tools to bring to life ideas that students have of how to grow plants in space and how to do things like deliver light and water. This is an interesting idea of how to deliver light evenly to the leaves of a plant stem. Growing in space using this sort of the light conducting plastic. And also students have worked on different ways of delivering water to plants in space, which is one of the biggest challenges. Different materials that wick the water and different methods of delivering it without letting it scatter. So there's all kinds of interesting potential ways to make growing plants in space more efficient and more feasible. And it's amazing to see how creative students have been able to be when they've been presented with this challenge. And then one of the other beautiful things is that the students, it kind of forces them to think of the general challenges of growing plants, because these are the same kinds of challenges we have on Earth, in many ways.
Yeah.
And but kind of many of the innovations in horticulture have occurred in difficult environments, and such as cold and dry places, and space is kind of the next step in that.
Now, when the student, you'd mentioned around 50 schools or so participating in the program, does one teacher within each of those schools take it on, or are there different mentors outside of the school that lead these conversations and these discussions? Do the students all convene and come here on one day with one mentor, or how does that work?
They usually it's individual teachers at different schools that are in science classes that interact with the garden here because we're doing this in over 40 states now, so they don't all come together physically. But the schools down here in South Florida, there are workshops for the teachers and for the students. They come regularly to the garden to do different programs related to the Growing Beyond Earth. So there's a lot of interaction and a lot of virtual interaction through virtual meetings, and through a lot of the data gets shared via Twitter and other social media, and they do get to interact with NASA scientists now and then, which is and the NASA scientists have actually found the data that's been produced. They've produced hundreds of thousands of data points on plant growth, and it's been a tremendously fruitful collaboration.
Every pun intended.
Indeed.
Thanks, Chad, for showing this. I mean, this just looks like a field day for any type of kid who loves science, all these different things that you could play with. I mean, we barely had a computer in the high school that I grew up, so to be playing with all these different machines and 3D printers and whatnot, that's exciting.
Absolutely. The potential now that students have to explore their ideas is just amazing. We have so many new tools, and and this is just beginning.
Since our community here is so international, I'd love to hear from you in the comments about what edible plants you think will work best to grow in a space station. I personally think a number of species of microgreens, including sunflower, bok choy, and mustard greens, would be interesting because it could take so little time for them to grow and provide fresh, available nutrients. So put your ideas in the comments below for folks to consider. And in the meantime, check out what we have in store with our online houseplant courses at homesteadbrooklyn.com and what we're growing on our sister channel over at Flock Finger Lakes. We'll see you in the next episode.